welcome to the Geometric channel. Today's lesson covers properties of parallel lines and transversals, specifically looking at the 5 different angle pair types that result from the setup of 2 parallel lines cut by a transversal. If you'd like to follow along and take some notes, you can go down to the description, click on the link, you can print off that guided notes worksheet, you can follow along right with me. So we're going to start with just a couple of definitions. First of all, parallel lines you probably know as 2 coplanar lines that never intersect. Looks something like this. We denote parallel lines by 2 little red arrows. So if you see those 2 little red arrows, you know that those 2 lines are parallel and will never intersect. And then we've got this line that comes down and intersects those 2 parallel lines at 2 distinct points. This is what we call a transversal. Okay, so a transversal is just a line that intersects 2 coplanar lines at 2 distinct points. These lines don't have to be parallel for this line here to be called a transversal, but today we're going to specifically focus on these parallel lines. So whenever we draw the 2 parallel lines cut by the transversal, what happens is we create a whole bunch of angles. So we've got 4 angles at this intersection here, and we've got 4 angles at this intersection down here. So we got 1, 2, 3, 4, 5, 6, 7, 8. So within these angles, we've got a bunch of congruent angles, and we've got another relationship that we'll look at here in a second. But really, even though we have 8 different angles, we only really have 2 different angle measures. Okay, so we can look at these angles, we can classify them based on where they are in the setup, and we'll give some names to these different angle pairs, and we'll look at some theorems that go along with them. So there's 5 different types that we're going to look at specifically today. The first type is what we call corresponding angles. Okay, corresponding angles you can think of as angles that are in the same position at each intersection. Okay, for example, if I look at angle 1 at the intersection here is in the top left-hand side of that intersection. Okay, so here's angle 1 right there. If I took that angle, I kind of slid it down onto the other intersection like this, well, what angle would it land on? So taking angle 1, sliding it down, it would land right here on angle 5. Okay, so this is an example of what it means for 2 angles to be corresponding. They're in the same position at each different intersection. So in this example, 1 pair of corresponding angles would be angle 1 and angle 5. You can tell that there are 4 different pairs of corresponding angles. I can look at angle 2 up here. I can see angle 2, which is in the top right-hand side of that intersection. If I slid angle 2 down, it would land right on top of angle 6. So you can translate these corresponding angles on top of one another. Okay, so angle 2 and angle 6 would be corresponding. And I can keep going. Angle 3 would slide down onto angle 7, and angle 4 would slide down onto angle 8. Okay, so these are corresponding angles. Now the next type of angle pair, what we're going to call, I'm going to abbreviate here so I can save some space. We're going to call these alternate interior. Alternate interior angles. Okay, so the name of these angles is going to tell us a little bit about this type of angle. We're going to start with the word alternate. So alternate in this case means on opposite sides of the transversal. Okay, so the transversal is coming down this way. We have angles on the left side of the transversal. So we're talking about 1, 4, 5, and 8. We also have angles on the right side of the transversal, 2, 3, 6, and 7. So if we're looking for a pair of angles that are alternate, I want 1 angle to be on the left side, I want 1 angle to be on the right side. Okay, the second part of this is interior. In this case, interior refers to the portion of this setup that is in between the 2 parallel lines. Okay, so we have interior angles, there's 4 of them. So inside or interior between these 2 parallel lines, we've got 4, 3, 5, and 6. So all those angles are interior because they're in between those 2 parallel lines. Okay, so when we put these 2 pieces together, alternate interior. So we're looking for 2 angles, one at this intersection, one at this intersection. that are on opposite sides of the transversal and in between the two parallel lines. We've got two pairs here. So I've got angle 4 would be alternate interior to angle 6. Okay, so angle 4 and angle 6 would be considered alternate interior. The other pair of alternate interior we can look at 5 and 3. 5 is on the left, 3 is on the right, one at each intersection, both in between the parallel lines. Okay, so angle 5 and angle 3 would be another pair of alternate interior angles. Okay, the third angle pair type, we're going to stay on the interior. This time we're going to call them same side interior. I've also seen these called consecutive interior. I'm going to go with same side. So again, I'm abbreviating SS for same side interior. Okay, so same side interior. If alternate meant on opposite sides of the transversal, same side just means same side. Also staying interior, so we're still in between the parallel lines here. You can probably tell pretty quick that a pair of same side interior would be like these two. So again, we're looking at one angle at each intersection point. So I've got angle 4, and then down here, angle 5 would be a pair of same side interior. And then on the right side of the transversal, these are both on the same side, angle 3 and angle 6 would be the second pair of same side interior. Okay, the next two, I'm going to kind of do these together because I think by now you're kind of going to get the picture here. So I've got alternate interior, same side interior, and then the last two we're going to go with alternate exterior, and then same side exterior. Okay, so the interior angles, we were staying in between the parallel lines. The only difference now with exterior is that we're going to be outside the parallel lines. So the four angles that we're looking at here now are 1, 2, 8, and 7. Those are outside the parallel lines. And now we just have to look at alternate versus same side. So starting with a pair of alternate exterior angles. So again, alternate means on opposite sides of the transversal. I need one on the left, one on the right. And exterior meaning I need to stay outside the parallel lines. So if I look at angle 1 would be alternate exterior to, down here, angle 7. The other pair, I've got angle 2 and angle 8. Okay, so those would be my alternate exterior angles. And the last ones here, we got same side exterior, again, same side, both on the left or both on the right. Exterior outside the parallel lines, we've got angle 1 and angle 8. That's one pair of same side exterior. And then on this side, angle 2 and angle 7 are my second pair. Okay, so that gives you an idea of how to classify these angle types. Now, a minute ago I said that even though there's 8 different angles, there's only 2 different angle measures. And the reason for that is the fact that these lines are parallel to one another. So I kind of want to start up here with my corresponding angles real quick. If I go back to a pair of those, okay, one pair of corresponding angles we talked about was angle 1 and angle 5. So remember, I'm just sliding one angle down onto the other. I'm just translating it. And because these lines are parallel, that translation keeps its congruency. So if I slid angle 1 straight down onto angle 5, because these lines are parallel, that angle measure is not going to change at all. So sliding one onto angle 5 will literally take that angle and just map it right onto the other. So angle 1 and angle 5, because those are corresponding, those two angles are going to be congruent. And that's the case with any pair of corresponding angles as long as those lines are parallel. So angle 2 sliding down onto angle 6, those two angles are going to be congruent as well. Okay, so there's a corresponding angles postulate that says as long as the lines are parallel, whenever you have two parallel lines cut by a transversal, corresponding angles will always be congruent to one another. Okay, so if I look at a pair of alternate interior angles here, so alternate interior, I can look at angles 4 and angle 6. Okay, those two are alternate interior. Now, because I already know that angle 2 and angle 6 were congruent, those were corresponding angles, And I know that angle 2 and angle 4 are what we call vertical angles. You've probably seen that before. Vertical angles are just two angles that are on opposite sides of an intersection. Okay, we know vertical angles are also congruent to one another. So angle 2 and angle 4, because they're vertical, are congruent. And if angle 2 is congruent to angle 4, but we already knew angle 2 is congruent to angle 6 as well because they were corresponding, then by the transitive property, angle 4 will have to be congruent to angle 6. All three of those angles are going to be congruent. Okay, and that is true for all pairs of alternate interior angles. So angle 4 is going to be congruent to angle 6. And because of that alternate interior angles theorem, alternate interior angles are always congruent if the lines are parallel. Any pair of alternate interior, like angle 3 and angle 5, would be congruent as well. Okay, so you can already see kind of how this is going to line up. I've got two pairs of congruent angles at 2 and 4. I know that angle 1 and angle 3, those are vertical angles as well. So I've got 2 and 4 the same, 1 and 3 the same. But I can really do the same thing down here at the bottom. 1 and 3 are congruent to 5 and 7. And then 6 and 8. Again, vertical angles 2 and 4 the same. So if I make my way down, same side interior angles, I'm going to skip that one just for a second. So I've got another pair of congruent angles in alternate exterior. So angle 1 and angle 7, that's a pair of alternate exterior. You can see that we've already got those two angles marked congruent based on the situation we have with the parallel lines. So alternate exterior angles, when the lines are parallel, will always be congruent as well. Okay, so the last two we have here are the same sides. Same side interior, same side exterior. Now, one thing that we know about straight lines in general is that if we have two angles that are adjacent to each other on a straight line, for example, angle 1 and angle 4, I know that a straight line is 180 degrees always. And if I have two angles next to each other on that straight line, their sum must be 180. Okay, so these are supplementary angles. So I know that angle 1 and 4 are supplementary. I know that angle 1 and 2 are supplementary. I know that 2 and 3 are supplementary. So if I take two angles that are next to each other at any of these intersections, they're going to add up to 180. And that's why I really only have two different angle measures at these two intersections. They're either going to be the same, congruent to one another, or they're going to add up to 180 with one another. So if I know that's the case, 1 and 4 are supplementary, but 1 is the same as 5, I've got 4 and 5 here, which is a pair of same side interior angles. 4 and 5 will have to be supplementary. They're going to add up to 180. And that's also true on the other side. These other pair of same side interior, angle 3 and 6, are also going to have to add up to 180. So any pair of same side interior angles, when the lines are parallel, are going to be supplementary. They're going to add up to 180. Now if I look at same side exterior, for example 1 and 8, it's going to be the same thing. So I can see that angle 1, that's my angle with one arc, angle 8, my angle with two arcs. Again, I can translate that angle 1 down to 5. Those corresponding angles being the same, they're going to add up to 180 here on that line. So 1 and 8, same side exterior. Same thing with angle 7 and angle 2, also same side exterior. Those are going to add up to 180 as well. Okay, and you can give you a real quick example here just so you can tell. If I said that maybe angle 1 was, we'll just call it 70. Okay, if angle 1 was 70 degrees, that means all angles with one arc, okay, so the vertical angle down here at 3, 70, the corresponding angle down here to the other intersection, if angle 1, 70, its corresponding angle is also 70, and the vertical angle down here. And I can go back through, go back up to the top 1 and 2. Those are two angles next to each other on a straight line. That's a linear pair. Those are going to be 180 degrees. So if 1 is 70, 2 has to be 110. And I can go around the horn here. This is also 110 because it's vertical. Corresponding angle straight down, 110. Vertical again, 110. Okay, so again, 8 different angles, but really only 2 different angle measures when those lines are parallel. Okay, so using this information, knowing that corresponding angles and then the alternate interior and alternate exterior angles will always be congruent, and then your two same side angle pairs are going to be supplementary, we can use that information to solve lots of different types of problems. So let's look at 3 quick examples here, and you can see how we use these. So let's start with a fairly simple one here. So let's say you've got two lines. We'll go ahead and say that they are parallel to one another. Always look for those arrows. That gives you the information that they are parallel. And then my transversal coming down. Okay, so this isn't drawn to any type of scale, but let's just put some numbers in here. So let's say this was a 30-degree angle, and maybe we're missing some angles down here. So angle 1, angle 2, and angle 3. Okay, so if we go back to our different angle pairs, if we can identify some of those pairs within this situation, we can find these missing angles pretty quickly, okay, knowing those rules. So let's start with corresponding angles. Do we have a pair of corresponding angles in this picture? The answer is yeah, we sure do. So I've got a pair of corresponding angles here, angle 30, which is what we know. If I translate that down to the other intersection, that would land right on angle 2. So top right, and we just said that we know that corresponding angles are always congruent when the lines are parallel. So I know that angle 2 is going to also be 30 degrees. So write that in right there. Okay, so can we identify another pair that we talked about using 30 and one of my other angles down here at the bottom? So you can see that 30, this 30-degree angle, is on the exterior. It's outside the parallel lines, and it's on the right. If I go down here to the other intersection, angle 30 and angle 3, with 3 being on the other side of the transversal, those are going to be alternate exterior. And we just said that alternate exterior angles, always congruent, lines are parallel. So 30, alternate exterior angles being congruent, also 30. Okay, so last one, angle 1. Can I pair it with angle 30? Can I classify this angle of 30 degrees with angle 1? Think about that for a second. Would angle 1 and angle 30 be one of those 5 angle pairs? In this case, the answer is no, it's not. Problem is, I know that angle 30 doesn't correspond with angle 1. I can't slide angle 30 down onto angle 1 like I could with angle 2, so it's not corresponding. But angle 30 is exterior and angle 1 is interior. Okay, so I can't have an interior and an exterior angle unless it's corresponding, and I could slide it down. So I can't really classify these two angles, angle 30 and angle 1, as any of those 5 angle types. But because we know, again, straight lines are 180, I do have a straight line right there. I've already got 30 degrees on the right. All of this has to be 180. So 180 minus 30 gets us angle 1. And that's going to be 150. Okay, so not always are you going to be able to classify each type of, or each pair of angles as one of those 5 types. But I can use what I know about straight lines and vertical angles and that sort of thing to find my missing angles. Okay, let's do another one. Okay, so in problems that you're going to see, not always is it going to look like just 2 parallel lines and a transversal. Sometimes they kind of, they kind of hide them in a situation. Something like this. Okay, so there's my lines. Let's put in some numbers. Let's go. Again, not drawn to any type of scale here. This is all 70 degrees. We'll go 65 right up here. And we're missing 2 angles. Okay, so you can see things look a little bit different here because we don't just have a pair of parallel lines and transversals. We kind of have to use our imagination a little bit. Okay, so the first thing I would recommend is identify where your parallel lines are. Okay, the parallel lines are here. Sometimes it's even helpful to just kind of extend them out a little bit. So I know that this kind of box shape here, this quadrilateral that we have, kind of bounds everything. But if I just extend out my lines a little bit, sometimes it's easier to see kind of what's going on. So my parallel lines are here. I have two separate transversals, one at this side, one at this side, and I'm going to look at them one at a time. Okay, so if I start over here on the left, I've got my two parallel lines here and here. I've got my transversal here. If I were to identify angle 60, the 65-degree angle with angle 1, which type would that be? They're in between the parallel lines. They're on opposite sides of the transversal. This is alternate interior. And knowing that alternate interior angles are congruent with the lines being parallel, I know they're congruent, they're the same. So I got angle 1, 65 degrees. Okay, I'm going to do the same thing on the other side here. So I got my parallel lines here. Here's my transversal. Again, these two angles are interior, they're in between my parallel lines. And this time they're both on the same side, they're both on the left. So same side interior, we know that those are supplementary to one another. So same side interior supplementary, they add up to 180, means angle 2 has to be 110. 110 plus 70 is 180. Okay, so the trick here, just identify those parallel lines, look at each piece individually, separate it out, okay, extend those lines out, makes it easier to see. Okay, we'll do one more. So another circumstance where you got a little bit extra. So not just parallel lines and a transversal, but a couple other things to wade through. Okay, so we got two angles this time, angle 1 and angle 2. Once again, the best thing to do is to identify where your parallel lines are. So I've got my parallel lines right here. And because it's helpful for me, just kind of extend out the parallel lines so we can see things a little bit easier. So parallel lines here and here. I've got two transversals. I've got one coming this way, and then I've got the transversal horizontally. Let's use that horizontal transversal here to start. So I've got parallel lines here, transversal, 80 degrees. I can take that 80 degrees and I can translate or slide that right over here onto angle 1. So I've got, again, the two intersections. 80 is in the top left corner of that intersection. Angle 1 is also in the top left. Those are corresponding angles. They are in the same position. So 80 slide over to 1. Corresponding angles are always congruent when the lines are parallel. Okay, next thing we've got is got 80 degree angle. I've got this entire angle here. Use a different color here. So this entire angle here, and then the 80 degree angle. Okay, these two are in between the parallel lines. They're both above this transversal, so these are same side interior. So we're talking about 80 degrees, and then this entire angle, the combination of 40 and 2, those are same side interior. And with same side interior being supplementary, adding up to 180, I really need to know what this entire angle would have to be, and then I can divide it out how I need to. So this angle being 80, same side interior being 180, 180 minus 80 is just 100. So I know that these two angles together have to make 100 degrees. And if I take 100 minus 40, what's left over for angle 2? It's going to be 60 degrees. So angle 2, 60 degrees. Okay, so the trickiest part of these really is just kind of identifying what's important and what's really not important in any given situation. If you extend out those parallel lines and really just focus on what's in between those or what's outside of those, and the transversal on either side of it, that's really what you're trying to do. Okay, hopefully that gives you a better idea of those 5 different angle pairs and the properties that go along with them. If this was helpful at all, you can leave a like. You can comment below what you'd like to see next, and subscribe to the Geomistic channel if you'd like to see more videos like this one. Thanks for watching. See you next time.